the same thing that we did yesterday, where we're writing and graphing equations of lines. Today, we're specifically going to talk about parallel and perpendicular lines. So we've probably seen these things before. We know what a parallel and a perpendicular line look like. Let's just talk specifics really fast. When I talk about parallel lines, the one thing that I am looking for with parallel lines is that they have, number one, the same slope. And in order to not be the same exact line, they have different y-intercepts. When you see a line that has the same slope with the same y-intercept, that means they're literally the same line. Sometimes you're going to see the word coincide. So two lines coincide or overlap if their slope and their y-intercept is the exact same. Our last one is perpendicular, and we know two lines are perpendicular if their slopes are opposite, meaning one positive, one negative, and reciprocal, meaning I take a fraction, I flip it upside down, right? We've seen this before. This isn't new for us. Okay, so what we're going to be doing is, number one, we're going to be identifying whether lines are parallel, perpendicular, neither, whether they coincide, all that good stuff. Let's start there. This says, are lines parallel, perpendicular, or neither, and explain. Are these two lines currently in a form where we can just look at them and tell what their slopes are? Okay, they're not. So what form can we put them in easily to figure out what their slopes are? Do you remember what that's called from yesterday? When we solve for y? Dahlia? Yeah, we're going to get both of these lines into slope-intercept form by solving for y. And when we solve for y, we get the form y equals mx plus b. We'll be able to really easily tell what our slope is because it'll be that m. So let's start here with the 10y equals negative 4x minus 20. To solve for y, that's really easy. I can just divide everything by 10. So this is y equals negative 4 over 10 reduces to negative 2/5. Negative 20 over 10 is negative 2. So the slope of this line is negative 2/5. I'm going to do the same thing for my other line as well. For this line, I have to first subtract 2x to get that to the other side. And then divide everything by 5 to get y equals negative 2/5 x minus 1/5. The slope of this line is negative 2/5. So are these lines parallel, perpendicular, or neither? They're parallel. Their slopes are the same. Oh, parallel was a word that we need to learn how to spell as well. We didn't misspell it too often, but I did see a couple. Same slopes. And what else do we have to check for? Different y-intercepts. Oh, those y-intercepts are negative 2 and negative 1/5. Those are different, so that's good for me. Any questions there? Okay, so if I have two lines on a graph and I want to figure out their slopes, what's the easiest way we can figure out their slopes? I'm going to count the boxes for rise over run. Slope we know is just the rise over the run. We are always going to count from left to right, like we're reading a book. So I'm going to look at that line on the top first, and I want to count its rise over its run. I'm always going to start with the point that's on the left-hand side. So this point right here. I'm going to count the rise first, 1, 2. So it's a rise of negative 2. And the run, 1, 2, 3, 4. Run 4. The slope of this line is negative 2 over 4. which reduces to negative 1/2. You see how we did that? I'm going to do the same thing for the other one. I'm going to count from the left point down 1, 2, 3, over 1, 2, 3, 4, 5, 6. The slope of this line, negative 3 over 6, or negative 1/2. So are these lines parallel? Yes. They have the same slopes, and they have different y-intercepts, so they are parallel. We see this part right here where it says explain using slope. That's there to tell you that I cannot just look at this graph and say, well, they look like they're parallel, so I think they're parallel. We have to do some kind of explaining. However you choose to find the slope of those 2 points is up to you. But counting is easiest. So like in letter B, can we tell something's up? Probably. You can probably tell that those lines don't look parallel, but we're going to count it anyways. Starting with the point on the left, I count my rise. 1, 2, 3, 4, 5, 6 is my rise. 1, 2, 3, 4 is the run. The slope is 6 over 4, or 3/2. And then same thing for the other line. I start with the point on the left. 1, 2, 3, 4, 5, 6. 1, 2, 3. The slope here, 6 over 3, or 2. Are they parallel? No, we can tell their slopes are different. That's it for that. Does that make sense? So then let's look at like the real stuff for this lesson, because what we're really trying to get at is writing the equations for lines that are parallel to other lines that go through a specific point. So if you remember, I'm going to zoom back to yesterday really fast. We did some of this stuff yesterday. We were just writing equations. We weren't trying to write equations for lines that are parallel. But if you remember the steps, number 1, we need a slope and we need at least 1 point. Okay, sometimes we had to do a little bit extra, like we did in this bottom one, to find the slope. But once we have a slope and a point, we use point-slope form to plug it in, and then we solve for y to get it into slope-intercept form. Those are our basic steps. We're going to continue to do the same exact thing on this page right here. So number 1 is to figure out what slope do I need for a line that is parallel to this line. If my line is y equals negative x plus 4, what's the slope of that line right there? Negative 1, right? It's a negative. The invisible 1 is in front of there. So the slope of this line is negative 1. So then what would be the slope of a line that is parallel to that line? Parallel lines have what kind of slope? The same. So if the original slope is negative 1, the parallel slope should also be negative 1. So that's step 1. Figure out what my slope needs to be. Step 2. Now I'm going to use point slope form. Let me write it down over here if we don't remember it. Y minus y1 equals m times x minus x1. My x1 and y1 are going to come from the points that they gave me. M is my slope. Let's plug it in. Y minus, y1 is 5. Slope is negative 1. X minus, x1 is negative 2. So minus a negative 2 becomes a plus 2. Any questions there? My final step, even though it's not really written here, is going to be to get it into slope-intercept form. Just like we said earlier, to get it into slope-intercept form, we're going to solve this for y. To start, I'm going to distribute. And then add 5. So my new line should be negative x plus 3. Pretty much 3 steps all the time. Any questions on that? Okay, if you're good, flip it over. Number 4, are these lines parallel, perpendicular, or neither? Casper. What are we missing? It's okay, I'm trying to trick you. Casper? Yeah, it's written like that to trick you. So we have to make sure that it's actually in slope-intercept form before we can make a decision. So let's subtract this 9/2 x first to get y equals negative 9/2 x minus 7. And now that it's actually in the correct form, are they parallel, perpendicular, or neither? They're nothing. They're not the same. They're not opposites. They're not, like, we got nothing here. These are just neither. All right, let's talk about perpendicular here for a second. Are the lines perpendicular? Explain using slope. Again, we cannot just eyeball this. We have to give some kind of justification. However we choose to find slope, the easiest way is to just count our boxes, rise over run, to find slope. So rise over run. Remember, we're starting from left to right, so pick a point on the left of your line and count. Down, 1, 2, 3, 4. Over, 1, 2, 3, 4. It would be helpful if I could draw straight lines. The slope of this line is negative 4 over 4, aka negative 1. Same thing on the other side here. I start with the left. I go up 1, 2, 3, 4, 5, 6. And to the right, 1, 2, 3, 4, 5, 6. My slope here is 6 over 6 equals 1. Are these perpendicular? They're opposite reciprocals. We can't tell that they're opposite reciprocals because they're 1, but they are definitely opposites. And if I were to write them as fractions, 1 over 1 and negative 1 over 1, those are opposite reciprocals. So yes, these guys are perpendicular. Let's do another one real fast here. Again, I'm counting from left to right, so pick the point on the left. Go 1, 2, 3, 4, 5, 6 up. 1, 2, 3, 4, 5, 6, 7, 8, 9 across. 6 over 9, aka 2/3. Same thing over here, starting with the point on the left. Down, 1, 2, 3, 4, 5, 6. Over, 1, 2, 3, 4. Negative 6 over 4 reduces to negative 3 over 2. Opposite reciprocals? Yep, 2/3 and negative 3/2 are opposite reciprocals, so these are perpendicular. Okay, almost done. 2 more. So again, now we're going to write our equation of a line perpendicular to this line. So we're following the same 3 steps. Figure out what slope do we need, write it in point slope form, solve for y. So first step, I got to figure out what slope do I need here. Well, what slope is my original line starting with? This line right here. It's not in slope-intercept form. So in order to get it into slope-intercept form, we got to solve for y first. So let's do that. I'm going to add x. And divide by 5 to get 1/5 x plus 2. What's my original slope of this line? What's the slope of this line? Casper? Slope is 1/5. So then what slope do I need for the line that I'm about to create that's perpendicular, Casper? Negative 5 or negative 5 over 1. That's the opposite reciprocal. So now I'm going to use this slope. And in step 2, I'm going to write it in point slope form with this point right here, 15, negative 4, x1, y1, in point slope form. Y minus y1 is plus 4 equals my new slope, negative 5, times x minus x1. And I finish it off in slope-intercept form. Subtract 4. Ooh, I got to distribute first, actually. Y plus 4 equals negative 5x plus 75. Subtract 4 on both sides. Y equals negative 5x plus 71. Good there. Do we see the 3 steps? Figure out the slope you need, write it in point slope form, and then typically you're writing it in slope intercept form. I think there might be 1 or 2 on the homework that ask you to put it in standard form too, but we did that yesterday. All right, last one. Letter A says we're going to find the slopes of these 2 lines. Letter B says we're going to determine if they're parallel, perpendicular, or neither. What is y equals 3? What's the slope of that line? Anybody remember? Casper? Vux ends with x equals. So what's the one that's a y? Hoi. So my slope is 0. Okay, this is a horizontal line. Y equals horizontal line this way. So what about this other one? What's the slope of this line? X equals negative 2. That's my other one, yeah. Yeah, undefined, that's my Vux. Undefined slope. Vertical line up and down. So are these parallel, perpendicular, or neither? Can we think about it? If I have a horizontal line going this way, and I have a vertical line going this way, what do they look like? Casper? They are perpendicular. So this is like one of those weird special cases where you're not going to get opposite reciprocals, but we still know that a horizontal line and a vertical line make perpendicular lines. Any questions on that?